Hi all, welcome to TutySpot. In this video, let's discuss the role of a lexical analyzer. First we will discuss about the lexical analysis. Lexical analysis is the process of converting a sequence of characters from the source program into the sequence of tokens. Those sequence of characters are called as lexemes. So in lexical analysis, the process of conversion of sequence of lexemes into the sequence of tokens takes place. The program which performs lexical analysis is termed as lexical analyzer or lexer or tokenizer or scanner. So while discussing about the lexical analyzer, we have to mainly discuss four topics. First is the role of the lexical analyzer, or it is also called as lexical analyzer functions. And second is the need of lexical analyzer. And third one is tokens, lexemes and patterns. And fourth one is lexical errors. So what is the role of lexical analyzer? As we already discussed, lexical analyzer produces a stream of tokens. This token can be a variable or identifier or constant or keyword or operator. We will discuss it briefly further. This lexical analyzer will remove comments and white spaces like blank spaces or new line characters from the source program. Suppose for example, consider int having some spaces a, b. We have 4 spaces here. Lexical analyzer will remove these unnecessary blank spaces. It counts line numbers of the source program. That means it will count how many lines did the program has. And it generates symbol table that stores information about the identifiers. Whenever the token is produced by the lexical analyzer, it stores the token information in the symbol table. And it provides error messages with the corresponding line and column numbers. Means it gives information to the error handler. The error handler reports it to the user. So here is the diagram specifying the role of lexical analyzer. See here, the source program is giving the input to the lexical analyzer. Then the lexical analyzer will produce tokens and send those tokens to the syntax analyzer. This syntax analyzer is also called as parser. The identified tokens will also be sent to the symbol table from the lexical analyzer. Lexical analyzer is also called as scanner. The parser, by receiving the token from the scanner, re-verifies it from the symbol table. If the token and the identifier in the symbol table both matches, then the parser sends the request to the scanner for the next token using getNextToken command. After receiving all the tokens, the parser then constructs the parse tree, and that parse tree will be sent to semantic analyzer. Here we return the task performed by the lexical analyzer. So it reads the source program, scans the input characters, group them into lexemes and produce the token as output. The identified tokens are sent into the symbol table. When lexical analyzer identifies the first token, it will be sent to the parser. The parser then receives the token and calls the lexical analyzer to send the next token. And this process will continue until the lexical analyzer identifies all the tokens. And during this process, white spaces and comment lines will also be discarded. And next, coming to the need of lexical analyzer. First is the simplicity of design of compiler. Means it will remove white spaces, comments and generate the tokens. Means it helps the parser easy its work. Second is the compiler efficiency is improved. Means we will get regular expressions from the source program. This lexical analyzer uses different buffering techniques for reading the characters in the program and speed up the compiler process. Third is compiler portability is enhanced. Portability is nothing but working on different platforms. This lexical analyzer supports compiler to enhance its portability. And coming to the third topic, we have to discuss tokens, lexemes and patterns. Token is a valid sequence of characters that are given by lexemes. This token is a pair of two components, token name and attribute value, written within the angular braces. Token name may be a keyword or constant or identifier or number, operator or symbol. Next is lexeme. Lexeme is a sequence of characters. Suppose take the example C is equal to A plus B into 5. Then the lexemes are C equal to A plus B into 5. And the tokens will be written within the angular braces as for C, token name is ID1 and attribute value is 1 and equal to is the assignment operator and A as ID2 where 2 is the attribute value. Next, plus is the addition operator B as ID3, 3 is the attribute value and into is the multiplication operator and 5 is the constant. The identifiers ID1, ID2 and ID3 are stored in the symbol table with attributes. Attributes are 1, 2 and 3. And next, patterns. Patterns are useful to define regular expressions or grammar rules. Here the only rule for identifier is it will start with a letter followed by underscore or a letter followed by digit followed by underscore. L means letter followed by underscore and D means digit, and the star represents 0 or more occurrences of this operation. For example, small a to z, these are letters followed by underscore, and then L means letters small a to z and capital A to z, lowercase and uppercase letters followed by digits 0 to 9 and followed by underscore, and star represents 0 or more occurrences of this operation. And next, coming to the lexical errors. Lexical errors are the errors thrown by your lexer when unable to continue, which means that there is no way to recognize a lexeme as a valid token for your lexer. If there is no any valid token, the lexical error will occur. It can be a spelling error or unmatched string or appearance of illegal characters or exceeding the length of identifiers. For example, if there is a spelling mistake like if is written as of, then the error occurs. Unmatched string like printf and 1 has to be written within the quotations, but here a quotation is missing, so the string is unmatched. Or insertion of illegal characters like insertion of unwanted operators or anything like hash, @ question mark or any symbol. It will also result in the lexical errors. And next, these lexical errors are handled either by deleting one character or by inserting the missing characters or replacing a character from remaining input, or sometimes source text is changed around the error point in order to get the correct text. This process is called as local correction. And the last option is panic recovery mode, where unmatched patterns are deleted from the remaining input until the lexical analyzer forms a well-formed token. This is all about the role of the lexical analyzer. Thank you.